In this video, we are going to work on publishing the order created event to RabbitMQ. But there is an interesting problem while sending this order created event to RabbitMQ immediately as we create a new order. If you take a look at our current implementation, in the order service, we have this create order method in which we are first validating the order creation request and then persisting the information into our database. So ideally, we can publish the order created event to RabbitMQ here. But the problem is this is a transactional method, which means whatever the operations, database operations we are doing is going to be run in a transaction, which means either all of them are going to successfully commit or all of them are going to be rolled back. But if you send a message to RabbitMQ here, and for any reason, if database commit failed and it throws some exception, and all of the changes you made in this method are going to be rolled back, but your message publishing to RabbitMQ is already happened, so somebody is going to consume that message, but the order information itself is not stored in our system. So that is the problem. So what is the solution to this one? So there is a proposed solution called Outbox Pattern. So let us take a look at what is the Outbox Pattern. So this is the problem right now we have. In a transactional method, we are trying to make some changes to the database, and then we want to push a message to the RabbitMQ here. And if one succeeds and other fails, that's going to put our system into inconsistent state. So instead, what we can do by following this Outbox pattern is, we make the changes, what are the changes required for our operation into the database, and instead of publishing the message, create a events table and persist the message that we want to send to some other system, to Kafka or RabbitMQ, to whatever the messaging system we want. So put that message into the events table in the database itself and run both of these steps in a single transaction. So that way, either both of them will succeed or both of them will fail. So that is what we want. So here, this is only database related operations that are going to run in a transaction. So either all of them will succeed or all of them will fail. Once this is done, we can have a scheduled job where we can read the events from the events table in the database and then publish the message to queue, and then either delete that message from the events table or update some status as published or something like that. So again, we are having the same problem, right? Like again, we are trying to update the database table and then publish the message. What happens if some failure happen? So the advantage with this one is, this scheduled job can retry again after the next interval, and then you can read those events that are not yet successfully sent and then replay it again. But there is a chance that suppose you have published a message to this queue, but again failed to update, and when the next run, it is going to read the same event and then publish it. So that problem is still there with this approach. So that is the reason why our consumers should be implemented in an idempotent way, which means they should be able to handle duplicate messages. That means for every message we are sending, there should be a unique ID that identifies the event, and then the consumers should somehow store that event ID, and then whenever they get a message, they should check whether this is a duplicate message or not, and then process it accordingly. So then you can think about why decoupling this is not solving this problem. So the real advantage is you are decoupling the process into two steps, so that the first business operation, the key business operation, you can handle it in a proper way, and then later, while communicating to the other systems by publishing these messages, can be retried n number of ways from the scheduled job. But you cannot do that if you try to apply the same logic here itself, because this is a one-time user operation that people are trying to perform, and you can decouple this and then you can retry n number of times from the scheduled job itself. Okay, so this is what we are going to implement. If we take a look at this card, there are many subtasks and we are going to do one after another, and explain the challenges of implementing database operations and sending a message as a single atomic operation. We did this, explain how Outbox Pattern tries to solve this problem. It is also done. Now create order events table and an entity for it and a repository for it and a service for it. So first let us start with order events table. So here I have already made those changes, and I will walk you through how each of these changes are implemented. So here I have created a new migration script in the order service, flyway migration script, create order events table. So here we are creating a sequence for this primary key, and then we are storing the order number, and we are creating a event ID. This is going to be a unique ID that is going to be generated. Usually we are going to use UUID, and we are storing event type, what type of a event it is. So there can be order created event, order delivered event, order cancelled event, order processing failed event. So there are different types of order event types. So we are going to store that information here. And the payload is the JSON representation of the actual event information that we want to publish it to RabbitMQ, and created updated columns here. So this is the table that we are going to store our order events. So then we are going to create order event entity. So again it is a JPA entity, and we have primary key, order number, event ID, and event type. So I have created an enum that represents different types of events: order created, order delivered, order cancelled, order processing failed. So these are different types of events that are possible. And we are storing a payload, which is a JSON payload, and created it, updated it, and setters and getters and all. So we have that entity. And then we have order event repository. Again, it's a simple JPA repository, and we don't have any custom methods so far. And then I have created, under models, I have created order created event. So in this event I have event ID, which is going to be a generated UUID to make a unique identifier for an event. So next we are storing order number, and we are storing all the items information in that order, and what is the customer information and delivery address, and when this event happened. So why we are storing all this information? So because we want to publish this event to other systems through RabbitMQ, and in our case the notification service is going to consume this information and send an email. So in that they may want to address by saying dear customer name, and then you have placed an order with all these items and it is going to be delivered to so and so address. So they may want to put all these details in the email. So we are publishing all the information as part of this event. And as I explained already, order event type, it could be one of these events. So with that, let us see what order event service has. So I have created a new order event service, and we have save order created event method, where it is going to take this event as an input, and then it is creating an order event entity. So we are taking event ID from that and then setting it as a order created event, because this is of type created. And then order number, we are storing it and then created it. And for the payload, we receive this order created event, and then we are converting that into JSON by using object mapper from Jackson library, and we are converting the payload entire order created event into JSON and then setting it to order event, and then we are storing that into our order events table. Okay, so this is one method. And so let us go to our order service. So here I have injected that order event service into our order service, and what we are doing, after we successfully persist the order information into our orders table, I am creating an instance of order created event from the order entity. So I have a helper written order event mapper and build order created event. So it is taking this order entity and creating a order created event. So the first one is event ID. So as I mentioned, we are trying to create a unique event ID, and currently we are using UUID, random UUID as an event ID, and then we are extracting other information required from the order entity, and finally we are returning this order created event. So once we have this order created event, we are calling this order event service save. So this we have already seen. We take the order created event and then convert that into order event entity and storing into order events table. So this is the first part of the story, like this one. We are making the changes, persisting the order information itself and then persisting the event information into order events table. So we have done this first part. Next, we are going to create a job, scheduled job, and then we are going to process those messages. So how are we doing this? So Spring Boot provides this scheduled jobs support, where you need to enable that scheduling by adding this enable scheduling annotation to our main entry point class. Once this is done, you can create a job. So here in our orders package, I have created a jobs package under which we have order events publishing job. So here what I am doing, I have injected this order event service, and then I have configured a property to specify the cron job when it should run. So I have configured that value in our application properties, publish order events job cron. So this is to run for every 5 seconds. So you can change depending on the environment you are running. So for now I set it to run for every 5 seconds. So here this method is going to run for every 5 seconds. So what we are doing here, we are just logging, we are going to start publishing the events at so and so time, and then we are calling this order event service dot publish order events. So what this method is doing, so here we created a sort by option, created it because we want to publish the events in the events created at sort. Based on that order, we should publish the events. So then we are querying repository, order event repository, find all by specifying that sort. So again, here because I am running this job for every 5 minutes, I am trying to get all the records at once. But if you are building a high scalable system and there could be hundreds or even thousands of records for every 5 minutes also, I would recommend to read using pagination. But here we are reading all of the events in a single go. And once we get all these order event entities, we are looping through it, and for each entity we are firing this publish event method in which we are actually publishing the event to RabbitMQ, and then we are also deleting that event from the repository. Okay, so what this publish event is doing, so here we take this order event entity and we are extracting what type of event it is. So currently we have only order created event. There will be more event types like cancelled or delivered. We will handle them later, but now we have only order created event. So it is going to read that from the database. So we already have this order event entity, and we are reconstructing this order created event from the JSON payload. So here again we are using Jackson object mapper and then converting the JSON string into whatever the type we are giving. So in this case we are specifying it should be converted to order created event class type. So we have reconstructed our object into our object from the JSON payload, and then we are calling this publish method on the event order event publisher. So we have created a new class called order event publisher. So here if you take a look at in our domain, we have new order event publisher. So this is a new class that is created which has Rabbit template and application properties injected, and we have this method publish of order created event. So here again we are calling a private method send and property start new orders queue. So this is the routing key. If you remember, we have configured the same routing key as same as the queue name itself. So we are sending that as a routing key and event. Okay, and right now instead of using order created event, we are using object, because going forward we are going to publish other type of events also, but here it doesn't matter. We are going to simply publish that event to RabbitMQ. So I generically make it as object type. So once we call this, we are actually calling Rabbit template.convert and send. So the first argument is exchange name. Again we have this configured, so we are calling order event exchange, and next one is routing key. So in this case this is going to be same as the new orders queue, and finally the payload. So RabbitMQ Rabbit template is going to take care of converting this payload into JSON and then publish it to RabbitMQ. Okay, so this is the second part of the story. So here we are publishing it, and then we are already we have already seen from the job we are as soon as we publish the event successfully, we are deleting that event. Okay, so imagine if one of the event is failed, in the next job execution it is going to read that and then resend the same message. So that is why we mentioned it should be, the consumer should be idempotent and should be able to handle the duplicate messages. So now we have all the things in place, and we should be able to place an order and see the message in the RabbitMQ GUI. We can get the message and then be able to see it. So before that, let me, earlier while demonstrating this publishing RabbitMQ, we have created this both RabbitMQ demo controller, and then we have created RabbitMQ listener. So I'm going to delete this. We have already seen how to publish and consume those messages. So I'm going to delete those two. So now we have all the implementation in place. So we are going to run this order service, catalog service, and place an order, and should be able to see the message details in the orders, new orders queue in the RabbitMQ. I have started both the catalog service and order service, and we have already running RabbitMQ catalog database, orders database. And when we started our RabbitMQ, we can access the management portal on port 15672. So here I am into the RabbitMQ management GUI. So here if I go to queues and streams and go to new orders queue, and here if you scroll down, there is a way to get the current messages. So we are pulling only one message, and right now there are no messages. Queue is empty. So now let us place a message, let us create a new order, and yeah, it is successful. Now as per our implementation, a new message is supposed to be here in this. So now let us pull the message and see. So it seems we got one message, and with the ID, event ID, this is a dynamic UUID, and order number is 4BE76 something. So let us go ahead and see. So 4BE76 something. So the same order created event information came into this RabbitMQ. So from the order service perspective, we are sending the information. You can even see the complete payload here. So we are sending the order created event to RabbitMQ successfully. We have completed all the subtasks of this publish order created event using Outbox Pattern card. So I'm going to move this to in review, and I'm going to start on this new card, implement new orders processing job. So far we have the logic where we are creating a new order with the status new, and we are already publishing a message to RabbitMQ with the order created event. But we need to proceed to process the orders. So how we are going to do that? We are going to create a new scheduled job in which we are going to fetch the orders whose status equals to new, and we are just simplifying the order processing logic here such that if the delivery address country equals to one of these, India, USA, Germany or UK, then we are going to automatically update the status to delivered, and then we are going to publish the message saying that order delivered event happened. Or if the delivery address country is not any one of this, we are going to automatically cancel the order, and then we are going to publish the message order cancelled to RabbitMQ. And during this processing of any of this whole order processing logic, if any exception occur, we are going to mark the status as order status equals to error. So this is what we are going to do now, and all these events are going to be consumed by our notification service, and then they are going to deliver messages to the customer if it is delivered or is it cancelled. So basically it is not to simulate how we actually process the order in a real e-commerce systems, but this is to learn how we can publish the messages from one microservices and then another microservice, how it is to consume. So it is to learn this process. So now let us go ahead and create a new job and then implement this logic. I have created other event models here. Order cancelled event. Again, it is very similar to order created event with all the fields, except that there is a new field called string reason. So we are going to include why we are cancelling this, that information. Similarly, we have order delivered event, again with all the information about the order, and order error event, again including the reason why this is failing. So once we created these other event types, in the order event mapper, I have added the static methods for constructing those event types from the order entity. So earlier we have already created this build order created event method. So similarly we have created for delivered event and cancelled event and error event. Okay, so these are the static methods that we have created. So with this in place, I have created a new job called order processing job. So here what I am doing, I am scheduling this job for every 10 seconds. So here I have created a new property to indicate this cron information, and this is to run for every 10 seconds. So once it triggers for every 10 seconds, it is simply calling this process new orders method. So as part of this, what we are doing, we are first trying to fetch the order entities with the status new. So we have added a new method in this order repository to return the order entities with the status given whatever the status is passed. So here we are saying fetch all the new orders, and then we are looping through all the orders and then processing it. As part of this process, what we are doing, first we are checking whether this order can be delivered or not. So here what we are doing, we had defined a list of strings, delivery allowed countries, list of India, USA, Germany, UK, and in this can be delivered, we are simply checking whether the order's delivery country is one of these list or not. So we are only allowing 4 or 5 countries, and we are just checking whether the order can be delivered to one of these allowed countries or not. So if it is, we are updating the status of that order to delivered. So here again we have added a default method in the interface itself. So first we are fetching the order by order number itself, and if there is no order with that number, we are throwing the exception. Otherwise we are setting the status and then saving it back. So here if we go back, if it is delivered, we are updating the status to deliver, and we are creating this new order delivered event and then saving into order events table. Okay. Else, if the delivery address country is not one of these allowed countries, we are updating the status to cancelled. So we are automatically cancelling it and then saving the order cancelled event into the order events table. But if there is any exception happened during this processing, we are simply setting the order status to error and also building this order error event and storing into order events table. So nothing complicated, but of course this is not how the order processing happens in the real applications, but here our purpose is to understand how to communicate between two microservices via messaging system. So we are processing it like this. Next, we have updated order event service logic here in publish event. Earlier we have handled only order created event. So we have added other scenarios as well, where we are dealing with order delivered, order cancelled, order processing failed. So all these events. So we are processing in the very similar way. We are taking the event payload and then converting them back into their Java beans, and then we are calling this publish event. And we have added all these other methods also. Earlier we have only order created event. Now we have added order delivered event, order cancelled event, and order error event to handle all of them. And in each of those cases, we are choosing which queue we want to send. So basically this is a queue name as well as the routing key. So we are sending the messages to different queues based on the event type. So, okay. So with the logic in place, I have just started both catalog service and order service. Now let us place a new order and see whether it is able to publish all the relevant events to this RabbitMQ. So here again I am placing a valid order with the country India. So here I am placing this order and order number is starting with 079. So now if I go to RabbitMQ and queues and streams tab, here first I'll check in the new orders queue. I get the message and 079, it starts with order number. So we got the message into new orders queue, and also it is supposed to be in delivered orders also. So here again I am going to get the message and it got the message 079. So it is successfully processed and then published the event to this queue delivered orders. Okay, so what if we publish a order with some other invalid value? So this is some unknown country. So if we place the order, it created a new order D7E, but if we go to cancelled order, we should be seeing this. So here in the cancelled orders D7E, the order is there and end up in cancelled orders. So it is, our logic is working fine. So I think we have implemented the functionality. We have implemented a new job and we have implemented this processing logic. So who is going to consume the message if there is any error? So here most likely we may have to create a listener within the order service itself and send a message to the support system. Obviously error messages, they are not supposed to be sent to customers. So we need to implement a listener and in the order service itself and send a message to the support team saying that one of the order processing is failed and maybe some backend job can be triggered to process those issues. So I will leave that to the viewers. If you want to implement that functionality to consume those error events and then take some action, I will leave it up to you. So with this, we have completed this as well. So next we are going to look at the next card, implementing the distributed locking for our job scheduler. And first we are going to discuss why do we need this, and then we'll take a look at how we can implement this. Next we are going to work on implementing this distributed locking for our job scheduler. So what is the problem we are trying to solve here? So in our application order service, right now we have implemented a couple of jobs to process various tasks. But Most likely in production environment, we might be running multiple instances of order service. If it is in Kubernetes environment, this can be run in multiple pods, or if it is in other environments, maybe you want to run multiple instances and then use load balancer to spread the load. But the problem here is, because we are using this Spring supporting job schedules, all of those services will be triggered this job processing. So there is no coordination saying that, okay, only it should run on only one node. There is no such a limitation here. So all of those nodes are going to trigger the same jobs and then try to process the same events, which is not what we want. We want at least, at most, only one node should start processing these events, and it should not be duplicated across multiple nodes. So this is where we are going to use a library called ShedLock. So basically what this will do, it will ensure that only one of the instances are processing the jobs at any point of time. So how does it do? So let us take a look at it. So basically it is going to use one of the persistence mechanism to store only one task is running on a particular node by locking that particular task. So if multiple nodes are trying to acquire the lock, it is going to prevent that and only allow only one node to process the jobs. So how we can do that? So first, if we are this ShedLock can be used by multiple frameworks in different ways. We are going to look at how we can integrate with Spring Boot application. So the first thing is we need to add this dependency. So let us go ahead and add this in our pom.xml. So let me add it here. Next, we need to create, we need to enable scheduler log. So I'm going to add this to our main entry point class, order service application. So here there is a default log at most for, so depending on how long usually our job processing takes, we can configure something. So I'm going to keep it as 10 minutes. Obviously for us it doesn't matter, it doesn't take much time. So but you can customize it based on the application needs. And once we enable that, we need to give a name to this task and use this scheduler log annotation. And within the log, within the scheduler task implementation, here first you need to assert logged. So it is going to first acquire the log and then check it is logged by the current instance or not. So let us go ahead and add this to our two jobs here. So here I will just give the same name here and also copy this to process new orders. Okay, and also we need to check whether we are able to acquire the log or not. Okay. So, but just adding these doesn't do any magic here. If you need, you want to customize at the job task level, you can also specify what is the minimum amount time and what is the maximum amount of time it can hold the lock and all. So coming to the main point, how this library is able to hold the lock, I mean preventing other nodes from processing the same task. So basically they are going to use a table. If you are going to use database, you can create a table, and also there are other approaches, like if you want to use MongoDB or some other database types, you can use it. But anyway, we are already using PostgreSQL, so we are going to use PostgreSQL table for implementing this log. So we are using Postgres, so we need to create this table. So let us add this table as a new flyway migration to our project. So here under migrations, let me create one v3 underscore underscore add ShedLock table.sql. So here I'm going to create this table. Okay, so when application starts, it is going to run this. So this is also done. Next, we need to we are going to use JDBC template to execute this one. So we are going to add this dependency as well. So depending on the type of storage mechanism you choose, you need to add this one, because we are using database, SQL database, we are selecting this mechanism. But if you are using MongoDB or some other type of database, you need to add another driver similar to this. So here we have added this JDBC template provider. And finally, we need to configure this log provider bean that look for where you want to use this mechanism to look for where is the logs and all this information. So that information is obviously going to store in this ShedLock table. So here we are going to configure this log provider, and let me copy this, and under config package I'm going to configure this with a name scheduler config. I'm creating a new configuration file here, and in that I'm going to use this. Okay, so with this configured, our services, even though if we start multiple instances of order service, it is going to ensure that only one instance is processing one of the jobs. So even if you have multiple instances, only one node is going to process this at any point of time. Okay, so this is all we need to configure. To actually demonstrate this, we need to run multiple instances and then see jobs are getting triggered only on one node. Okay, so let us try to do that. Within the order service, I have run the maven clean package command, which executed all the tests and then finally built the order service jar file within the target folder. So now what I will do, I will run two instances of order service on different ports from two terminal instances. Here I have terminal 1 window and second window here, and I am inside this order service. So in the first window, I am starting the order service application on 8082 port. So we can customize the port by passing this VM argument using -d server.port equals to 8082. And similarly, on the second window, I am customizing it to start the server on port 8083. So here, let me start this both the instances. So here you can see both the applications are started running on two different ports. One is on 8082, another one is on 8083. Now here we can observe the jobs are going to be executed only on one instance at a time. For example, here if you see found 0, so last one is found 0 new orders to process, but here that is not executed now. So here you can check found 0 order events to be published. So the other job got triggered here. So each task execution happening only on one instance of the service. It is not happening on both the service. So as you can see, at any point of time, one task is being executed only on one instance, not on the both instances. So we are done with this card as well. Finally, I think we have completed all the aspects of creating a new order API. So next we are going to start working on implementing the other API endpoints, like getting orders for a customer or getting a particular order for the given order number. So we are going to work on this in the next video. Thanks for watching. Bye bye.